Today's lesson, which one is the stronger reducing agent? Water or hydrogen sulfide? In this lesson, we are going to learn atomic size and strength of bonds, and then reaction and comparison between water and hydrogen sulfide as reducing agent. So let's begin. Atomic size and strength of bonds. Let's see the matter. Here, oxygen and sulfur are involved. These elements belong to column 16 in the periodic table. Oxygen, sulfur, selenium, tellurium, polonium, and finally livermorium. We know from top to bottom along a column in the periodic table, atomic size increases. Suppose this is oxygen atom, sulfur, selenium, like this. That is, from top to bottom along a column, atomic size increases. So we can say that sulfur atom is bigger in size than oxygen atom. Now let's see strength of bonds. In water, hydrogen oxygen bond is present, and in hydrogen sulfide, hydrogen sulfur bond is present. Oxygen is sp3 hybridized atom, sulfur as well sp3 hybridized atom. Hydrogen oxygen bond is formed by overlap of 1s orbital of hydrogen and 2sp3 hybrid orbital of oxygen. Here, difference in principal quantum numbers is only 1. But in this case, hydrogen sulfur bond is formed by the overlap of 1s orbital of hydrogen and 3sp3 hybrid orbital of sulfur. So here, difference between principal quantum numbers is 2. The more the difference in principal quantum number, the bond will be weaker. So this bond is weaker bond than hydrogen oxygen bond. Hydrogen oxygen bond enthalpy is 464 kilojoule per mole. On the other hand, hydrogen sulfur bond enthalpy is 376 kilojoule per mole. So hydrogen oxygen bond is a stronger bond than hydrogen sulfur bond. That is, huge amount of energy is required to break this bond compared to hydrogen sulfur bond. Let's move on to the next point. Now the point is reaction and comparison between water and hydrogen sulfide. Let's write the reactions. Water, which is liquid at normal condition, reacting with chlorine. Chlorine is gaseous at normal condition. Here, hot water is required because we know hydrogen oxygen bond in water is a stronger bond. That is why heat is required. The products are HCl aqueous because here water present, and oxygen which is gaseous at normal condition. Let's balance the reaction. 2 hydrogen atoms, here 2 hydrogen atoms, 2 chlorine atoms, here 1 oxygen atom, here 2 oxygen atoms. It should be 2 then 4 hydrogen atoms. It should be 4 chlorine atoms. Here now 4 chlorine atoms. Now the reaction is balanced. Here oxidation number of oxygen is -2, hydrogen +1. Oxidation number of chlorine is 0. Here hydrogen +1, chlorine -1. Oxidation number of oxygen is 0. That is, oxidation number of hydrogen is +1 in reactant, and in product this is +1. So no redox happens here. But in case of oxygen, we see 2 oxygen atoms, that is 2 oxides changes to oxygen molecule with 0 oxidation number. That means 2 oxides releases 4 electrons. This is oxidation reaction. These 4 electrons are accepted by 4 chlorine atoms, that is 2 chlorine molecules, and then chlorine changes to 4 chloride ions. 4 chloride ions. That is, here chlorine is reduced to chloride ion. This reduction happens by the oxygen, that is by water molecule. That is, in this reaction, water molecule reduces chlorine to chloride ion, giving these 4 electrons. In this way, here water molecule reduces chlorine. Now let's see about hydrogen sulfide. Hydrogen sulfide, which is gaseous at normal condition, chlorine gaseous. This is gas because here no water present, and sulfur, which is solid. Oxidation number of hydrogen is +1, sulfur is -2. Oxidation number of chlorine is 0. Here +1, here -1. Oxidation number of sulfur is 0. Let's balance the reaction. 2 hydrogen atoms, here 1. So this is 2 chlorine atoms, 2 chlorine atoms, 1 sulfur, 1 sulfur. Now the reaction is balanced. Here oxidation number of hydrogen is +1 to +1. So no redox happens in hydrogen. But in sulfur, oxidation number 2, that changes to 0 oxidation number. That means sulfide ion donates 2 electrons. These 2 electrons are accepted by chlorine molecule to form 2 chloride ions. 2 chloride ions. So here hydrogen sulfide reduces chlorine to chloride ion, giving 2 electrons. That is, in this reaction, water reduces chlorine, and in this reaction, hydrogen sulfide reduces chlorine. But which one is a stronger reducing agent? Here, there are 2 points. One is bond strength, that is, hydrogen-oxygen bond is a stronger bond than hydrogen-sulfur bond. That is why to occur this reaction, heat is required, but this reaction occurs at room temperature because hydrogen-oxygen bond is a stronger bond than hydrogen-sulfur bond. This is number 1. Number 2, in case of water, oxide ion is donating electrons, but in case of secondary reaction, sulfide ion is donating electrons. Which one donates electrons easily? oxide ion or sulfide ion? Let's see the matter. Oxygen, which is smaller in size, but sulfur, which is larger in size. Oxygen with two negative charge, sulfur with two negative charge. Here, in case of oxygen, distance between nucleus and electron cloud is lower than in case of sulfur, because sulfur atom is larger than oxygen atom. That is why in case of sulfur, electron cloud remains away from the nucleus. That is why in case of sulfur, electron cloud is loosely bonded to the nucleus. But in case of oxygen, electron cloud is strongly bonded to the nucleus. That is why sulfur can donate electrons easily, because in case of sulfur, electron cloud is loosely bonded to the nucleus because of its larger size. As sulfur is bigger in size, sulfur can donate electrons easily. That is why hydrogen sulfide is a stronger reducing agent than water. This is all about reducing agent between water and hydrogen sulfide. No more today. Thank you very much.